Hey, it's Mrs. Golding. I am in your packet number 2. We're in section 8.2 today on page 590. And I wanted to tell you that I was looking at my viewership on YouTube, and I noticed it's way down for packet 2. All I can assume is that it's helpful to be using your textbook with the videos that are already embedded in the packet, and you have the answer key at the back of your packet. So, from this point on, for sections 8.2, 8.3, and 8.4, I'm only going to be making videos for the guided practice in those sections. But if you need an additional video, there's something you can't figure out, you want to know more about, please email me and I'll be happy to make you a video. No problem at all, okay? So, first problem here on page 590 says describe the relationship between the terms in this sequence. And a sequence is just a list of numbers, and there's usually a relationship that we can find. An arithmetic sequence involves adding something. It also looks like subtracting, but most people would say arithmetic is adding because you are adding a negative or something to make it smaller. But it looks like sometimes adding and subtracting. A geometric sequence looks like we're multiplying or dividing. Some people would say it's only multiplying technically because when you're multiplying by 1/3, it's the same as dividing by 3. So that's the difference between arithmetic and geometric sequences. That becomes a big deal in 8th grade. So this is going to kind of help you get ready for that. Describe this relationship of what's happening. 13, 26, 52, 104. Well, I've been playing with these numbers long enough that I know 13 and 13 is 26. And I know that 13, if I'm really adding what 13 and 13 is 26. 26 and 26 is 52. So it looks like I'm adding something, but really what I'm doing is doubling the number every time, right? So we're just going to say that when we multiply by 2, that's the relationship. Okay, it's as easy as that. And I'm just going to write it like that. Multiply. There we go. Okay. Then write the next 3 terms. Okay, so 104 times 2 is 208. Is that right? And then if I take that times 2, let's see, 8 and 8 is 16. Is it 416? Yeah. And then 16 and 16 is 32. And 4 and 4 is 8. Did I get that right? I think so. So those are the next ones. Okay. Now it says you're going to use words and symbols to describe the value of each term as a function of its position. So it can be the first term in the position, the second term. In other words, if you wrote this with commas, it'd be 2, 4, 6, 8. Instead, they gave it a position number. Okay, so we're going to find the value of the 15th term. Well, what's happening here in this relationship? We're multiplying the position number by something every time. So what are we multiplying it by? Let's see, 1 times 2 is 2. 2, and I'm looking right here. 2 times 2 is 4. 3 times 2 is 6. And 4 times 2 is 8. So we need to find n times 2 to get this, right? Okay, so the first thing we're going to do is we're going to use words to describe what we're saying here. So in our words, we're going to multiply position by 2. Okay, and then we know that we're looking at this as our function, and they tell us n is 15. So 2 times 15 equals 30. All right, check back with me.